Okay, so now I want to talk about arrhythmias. So, arrhythmia is defined as deviation from normal rhythm. So, this could be because the rhythm of the heart is no longer this many impulses per minute, but let's say the impulses have increased or the impulses have decreased. Sometimes it's not only about the number of impulses per minute. So let's talk about how we define. So it could be heart rate, yes. So when we talk about heart rate, we are talking about increased or decreased. So in increased, we're talking about simple, paroxysmal, flutters, or fibrillations. Those can occur. And then when we talk about decreased, which is also known as bradycardia, the other one is known as tachycardia. So in bradycardia, decreased can also be mild, moderate, or severe. So that's the first descriptor. Second descriptor is um, initiation. Okay, initiation of the impulse. So initiation of the impulse is normally from the SA node. So this could be abnormal in that you have several more impulses happening, and this is because of supra ventricular activity. So supraventricular means anything above the ventricle. So you're talking about the atria and the junction. All right. So the atria and the junction are supraventricular, or it could be because of ventricular activities. So in the ventricle, we can also have issues that either slow down or increase the rhythm of the heart. Then we can talk about propagation. So propagation normally is the normal path that we had learned about. So if it comes off the normal path, then we see that there's a disturbance in the rhythm. Last but not least, we're talking about speed. We had talked about delays that happen, or even how much time is spent in each of the parts of the heart. So if that is disturbed, we're also talking about arrhythmia. So I just want to talk about the impulses for a bit, and I'll start with the supraventricular. So let's start with the atrial area. So in the atrium, we see that the SN nodes can increase its firing physiologically because of the sympathetics, or can decrease because of the parasympathetic. Pathologically, we see that the RR can be shortened due to hyperthyroidism, and can be slowed down due to hypothyroidism, hypothermia, obstruction jaundice. And this, if you have these two happening, the increase and decrease, you can actually have syncope going on. So let's look at tachycardia in this area. The first one is what I will call as simple. A simple increase in tachycardia is a simple increase in heart rate, which is tachycardia, I beg your pardon, is where you have more P waves that are going on, but distinctively you will have it conducted into a QRS. One of them will be conducted into a QRS. So you might have a P and another P, and then you might have the segment and then QRS. And or you could have a P, 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 maybe even another P, and then that's when you have your QRS and so on. So this one is known as a simple tachycardia. Then we have what are known as flutters. So in flutters, we have P waves that are known as capital F waves. So in these waves, you find that they are not as defined as what we see in the P waves. You actually, let me just draw how they look like. So in F waves, you find that the atria activity is pretty fast, and then they're not well recognized like the P waves. So they appear to be like this. Okay, all right. So they're not really. They do not really appear like the periods. When we start appreciating the ECG itself, we will look at a few of these. Then we have the third one, which is noted in fibrillations. And fibrillations, you were talking about a heart rate of over 350 beats per minute. And what you see is you just see very undefined as well. You have a record of very undefined P waves, but they're noted as small f waves. And then you have your QRS, and then it could have a T, and then they'll continue like that. So in these ones, we could have several vectors that are present and are being recorded. So you have several initiating points from the atria that are all pausing ectopic or foci, or bringing in more action potentials. And so in recording what is happening in the atria, instead of having a good P wave, you have so many of them happening, and they become very undefined. So that is what you're going to see. All right. Then I want to talk about number 2, junctional. All right. So for junctional, I want to start by talking about bradycardia. So bradycardia will be the delay being exaggerated in the EV. So if you noticed, you see that this junction is there to have a form of delay. But if this delay is further delayed, so to speak, then we have a problem. So these have been put in degrees. We have the first degree, they're actually known as heart blocks. So we have the first degree heart block, which is just noted as a lengthy PR segment. So what you will see is you will see a P and then a very lengthy segment, and then you will find the QRS. So in this component, you will actually notice that depolarization of the ventricle will take place because of activities in the supraventricular area. But when you come to the second degree, now the second degree has several types that I'm going to give you the basics first, and then actually give you some homework to read up on how this can vary. So what you will see in the second heart block is that there's more severity of the exaggeration of this segments, in that you're going to see some P waves not actually producing the QRS. So what you're going to see is you will see a P wave segment, all right, and then you'll see the QRS, and then you'll see the T. Then it will continue, and then you have a P, and might have another P, and even a second P, and then that's when you see a segment. And you will notice that in this case there's actually no QRS happening here. Now these can be different, all right. They are different in that, in fact, let me just go back here, okay, and not exaggerate this. what you are really going to see is that if this is the T, you're going to have your P, then you're going to have this just large exaggeration with no production of a QRS. This is this is the principle, that there is no QRS that is formed because of this P. So I want you to go to Ganong and read on morbits with a Z, morbits 1 and morbits 2. All right, and see how these patterns can actually be different. So in the third one, it's actually known as complete heart block. So in the complete heart block, we are talking about none of the P waves forming a QRS. So this results in the following. So you have the upper part, supraventricular area, coming up with impulses. And these impulses are going to form P waves. But when they reach here, you find that they are completely blocked. And then in its own time, the AV is going to then shoot out impulses, all right, that are not even in sync with when it received the P wave, because it has delayed so much. So once that happens, that is when you're going to have the QRS happening. So in this type, you're going to find no synchronization. Actually, it could be 2 P waves, it could be 3 P waves and then a Q, or it could actually be a P wave and then a Q, and then just like that. So there's no synchronization. You can't really find a pattern, because one is operating in its own rhythm and the other one also is operating in another rhythm. The other one is now junctional tachycardia. So that was bradycardia. So in tachycardia, you find that there are bundles that could directly affect the AV, making it put out impulses, all right, at a faster rate than normally. So you find that there's excess impulses that are being given out, and this will lead to less PR segment, and so on and so forth. Then the ventricles themselves also have an issue, in that sometimes you will have irritable foci within the ventricular area due to ischemia, and these will be throwing off ectopic action potentials, which will then be forming their own QRS T complexes. So I want you to read up on infarction and how this can lead to ventricular tachycardia or arrhythmias. Also read up on torsade de pointe, and also see how that affects the ventricle. So for now, that is all I'm going to talk about when it comes to rhythm and arrhythmias and the ECG. In the next class, we are going to talk about the mechanical responses to normal electrical impulse. Thank you.